Hello everyone, my name is Mahmoud Hassan Shiab. I'm from Triple E department. I'll be the first presenter of this presentation. So this presentation topic is about the line follower robot using logic gates, its demonstration and how it works. So before going into that, I'd like to introduce my teammates. They are Sanjit Hassan, Umme Habiba, Muntaka Maliat and Abhishek Chandra Prattoy. So let's move on to the next slide. So this slide is about the table of contents. So basically we have divided the project into different contents to understand the project. First, it is introduction of the project, the objectives of this project, components that we have used in this project, the system model of the line follower robot, the working principle of this project, and the simulations of the project, the project's prototype, result and discussions, applications, what the applications and what are the future scopes of this project, the advantages and disadvantages of the line follower robots, the conclusion of the project, and lastly the references. Let's on to so first the introduction. So the introduction is about the line follower robot. So what is the line follower robot? So as the name suggests, the line follower robot is an automated vehicle that follows a visual line embedded on the surface. So basically the path is predefined and can be either visible like a black line or on a white surface with a high contrasted color, or a white line with a on a black surface with high contrasted color, or it can be invisible like a magnetic field. So definitely this kind of project robot should sense the line with its infrared ray sensors that installed under the robot that we have used in this project. After that, the data is transmitted to the processor by specific transition buses. In this case, we have used the logic gates as a transition buses. So when the infrared ray sensor detects the line, then it transmitted the data into the logic gates, and the logic gates operates the control driver, and hence the robot starts to move on its own. So let's move on to the next slide. In this section, we'll talk about the objectives of this project and how we can achieve it. So first, we have to understand and the application of the digital logic gates. So in this case, before implementing the logic gates in our project, we have basically learned the real world scenario and practical scenario of it. Then we implemented it in the project. So in this project we have basically used NOT gate and OR gate. Then the design and implement of line following robot. So we have to make sure that the line following robot is successfully detecting the lines and moving and following the lines on the floor. Then the promote of automation. So basically in this era, the automations uses of automations is very versatile. We can see that they're using in various industrial manufacturings and healthcares. The creative exploration. So basically, in by doing this project, we have enhanced our creativity and explored many stuffs. Like different sensor configurations. We have learned about different algorithms, the line patterns, and to how to improve and upgrade the project. So these are the objectives of the project, and that's it from me. Now my next fellow group member will conduct the next part of the presentation. Thank you.
Assalamu alaikum. I am Ummi Habib. Here is the component part of our project. Here we use two IR sensor to detecting the line, and the line will be black line on the white surface. Here we use two IC, which one is NOT gate and another is OR gate. Those IC or the gates will help us to give the sense to the sensor, and and it will help to run the motor. Here we used DC motor to drive the wheels of the robot. Here we used a robot chassis that will support and hold all the components. Here for the power supply we use 12 volt battery to the motors and 5 volt to the motor driver. Here we used motor driver for control the DC motor and the wheels that will allow the robot to move and follow the predefined black line. Here, black tabs are used for following the line and give the sense to the sensor. Jumper wires are used for connecting in electronic components together, and breadboard are used for constructed the constructed the circuit. System model of this project. In here we can see two part. One is flowchart and another is block diagram. In the flowchart part we can see that if the we have used two IR sensor. One is left IR sensor and another is right IR sensor. If both sensor are on, then the robot will move forward, or it will finish the line, and the robot work only on the black line and one white surface. If the right sensor are on and the left sensor are off, then the motor will turn right, and motor will turn right, and the right motor will run, and left motor will stop. And if the right sensor are on, then the left motor will be stopped and the right motor will run. If both of the sensor cannot sense any line, then the motor will lean forward. The motor will move forward, and also the robot will move forward. Here the block diagram of our project. In the project we can see that we have used two IR sensor. One is left IR sensor and another is right IR sensor. Those sensors are connected to the NOT gate and the OR gate. The NOT gate and OR gate are the key component of our project, and those gives the sense to the sensor to drive the motor. Here we have and those IR sensor are and the logic gates are connected to the motor driver. In the motor driver we have used left motor and another is right motor. For running the motor we have used 12-volt battery power supply through motor driver, and we have used also 5-volt battery supply to the motor driver, and for logic gate we have used also 5-volt battery, and also 12-volt battery are connected to the IR sensor.
Thank you, Habiba. Assalamu alaikum, sir. I am Shanzit Hassan, and I will talk about the working principle, simulation, and the project prototype. Here is the working principle. I will discuss each of every component's working principle, and as you can see in this slide, we just use two logic gates, OR gate and NOT gate, to implement our project. As you can see in the slide, we added OR gate and NOT gate symbol. We also added the truth table of OR gate and NOT gate. And here the output will be 1 for OR gate when any input will be 1, and for the NOT gate, if we gives in input low and output will be high, and similarly if we give in the input 1, the output will be 0. And then the sensor principle, uh, here we use just IR sensor, two IR sensor, and the sensor will detect the black line and the white line. Okay, this is the main working principle of our project. As you can see in this slide, basically the left side of slide, this is the robot, and it on the black line. In this sense, the two sensor just detect the black surface and the black line in middle of the robot. In this condition, the robot will run continuously. And the second picture, when the left sensor detects the black line, the robot will turn the left side, and then the next picture, if the right sensor detect the black line, then it turn the left side, and if the two sensor detects the black line, the robot will be turned off. Basically, the motor will not run. Okay, this is the simulation of our project. As you can see, we just use a motor driver and the logic gate, OR gate and NOT gate, and two sensor. Here we added a truth table, and here 0 means the sensor does not detect anything, and 1 means the sensor detect something else. Uh, it means that it detects the black line, and I want to play a video. uh, yes. Okay, it's 0 means it does not detect anything, and two motor is running, then one sensor off, two sensor offs. It means the two motor stop. Okay, that's it for simulation. Okay, this is the simulation of our project. As you can see, we just use a motor driver and the logic gate, OR gate and NOT gate, and two sensor. Here we added a truth table, and here 0 means the sensor does not detect anything, and 1 means the sensor detect something else. It means that it detects the black line, and I want to play a video. uh, yes. Okay, it's 0 means it does not detect anything, and two motor is running, then one sensor off, two sensor offs. It means the two motor stop. Okay, that's it for simulation. Okay, finally this is our project prototype. Now we made the robot. As you can see in this slide, we just added the four picture and a video. And before starting the video, I want to say something about our project. To implement our project, we just use a two motor driver, because when we start with a driver, then we don't know what is going on. But the one motor driver now was dead. Basically, the one side was dead. For this cause, we just implement the another motor driver to run the another motor. And after that, this is the video. So let's enjoy the video. Okay, that's it for me, and my next groupmate will continue from the next slide. Thank you, sir, and thank you everyone for your kind attention.
Assalamualaikum everyone, my name is Muntaka Maliat and my ID now is 2043281. Today I'm excited to share the results and discuss the successful implementation of logic gates in a line follow robot project. Our team focused on integrating various logic gates including OR and NOT gates. Speaking of logic gates, the IC7404N and IC7432N were instrumental in analyzing sensor inputs and determining the robot's next move. These logic gates integrated seamlessly with a robust architecture, providing a robust control system. The key achievement lies in ensuring smooth logic operations, enabling the robot to interpret sensor inputs effectively and guide itself along the specified path. One of the highlights is the precise line following capability demonstrated by the robot. Utilizing infrared sensors, we showcase the robot's ability to accuracy. While the wheels allows the robot to move and follow the defined path, achieving precision in tracking and adjusting the robot's movement based on the detected line has been a significant milestone for our project. Another noteworthy aspect is the adaptability in line variations. We rigorously tested the robot's performance under different line shapes, angles, and color variations. The implemented logic gate configurations played a crucial role in enhancing the robot's adaptability to change in the line. In summary, our line follow robot projects successfully utilized the logic gates to create a counter system that not only interprets sensor inputs effectively but also ensures the robot's precision in following complex paths. It was successfully utilized infrared sensors, DC motors, a sophisticated motor driver, and a reliable power supply to achieve the precise movement and adaptability on defined path. In this slide, I'm going to talk about the applications and future scopes of line following robot. A line follower robot equipped with advanced logic gates and configurations open up a wide range of applications in different industries. Firstly, it can be employed in automation-guided vehicles, providing an efficient and automated solution for material handling with industries. In warehouse management, the robot proves to be a valuable asset, offering accurate and reliable assistance in organizing and transporting goods. The application extends to the field of education and research, where the robot can be used to teach and study robotics principles and logic gate functionalities. Additionally, the line following robot is suitable for patrolling and surveillance, offering a cost-effective and efficient solution for monitoring the designated areas. Looking ahead, the future scopes for line following robot projects are promising and diverse. Interaction with AI is a key avenue, allowing the robot to collaborate with artificial intelligence systems for more sophisticated decision-making and problem-solving. Collaborative robotics is another exciting prospect, where a robot can work alongside humans in a cooperative and safe manner, improving overall efficiency. Energy efficiency and sustainability is critical in considerations for the future. Our project aims to explore ways to enhance the robot's energy efficiency and contribute to the sustainable practices. And machine learning integration is on the horizon, providing opportunities to further improve the robot's learning capabilities and adaptability to evolving environments. Lastly, warehouse communication will play a crucial role in future development, and our line following robot can play a big part in this. In conclusion, our line following robot not only has practical applications today, but also holds immense potential for growth and innovation in the future. That's all from me, and my next group member is going to discuss the next slide. Thank you.
Hello everyone, I'm Abhishek Chandra Prattoy. Now I share with you the advantage and disadvantage of our project on the line follower robot using logic gates. And let's start with the advantage. Our robot represents a remarkable synergy between digital electronics and mechanics, built upon the foundational logic gates. And this results in a robot that can autonomously navigate a predetermined path and impressive accuracy. It's a simple yet powerful demonstration of how logic gates control a physical device in the real world. Moreover, the simplicity of the design makes it cost-effective and accessible for educational purpose, providing a hands-on tool for teaching the basics of robotics and programming. Its low power consumption is another significant benefit, making it sustainable for extended use. However, like all projects, there are some disadvantages to consider. The robot's line detection range is limited to the visible track it follows. This limitation means that it's not yet equipped to handle complex terrains or navigate without a clear path. Intersections pose a particular challenge, requiring further development in sensor calibration and programming to handle such intricacies. Additionally, the robot's reliance on contrast for detection means that varying lighting conditions could affect its performance. In conclusion, our line follower robot is a brilliant example of how simple components, when organized with thoughtful engineering, can create an educational and functional robot. It's a step toward the future of robotics, showing that even with some limitations, there's a vast potential growth and application in various fields. Our line following robot project demonstrates the seamless integration of logic gates and robotics, resulting in an autonomous system capable of intelligent path following. Through the use of infrared sensors and well-designed logic gate circuits, our robot showcase the synergy between hardware and software components. Despite challenge, the project lays the groundwork for future improvements, making it a stepping stone for innovation in the realm of robotics. This project not only signifies a successful collaboration of technology but also hints at the promising future of robotics. Here are the references that we mentioned in the slide we used to make our project and presentation. Thank you.